All right, guys, so this is the video I said that I would make. It's to explain the Ford Fulkerson's algorithm for maximal flow. Basically, we're trying to get from O to T. We've got a pressurized system. It's best to think about these as a system of pipes that have certain capacities. Like this pipe can send 8 liters that way. This pipe can send 9, and that's kind of how this graph works. So you got flow coming in from this way and going out from that way, and we're basically trying to figure out how much flow is going to come out of T whenever 16 is put into O. So the way that I know that, well, actually, no, I'm sorry, that's not 16, it's 17. So you got 17 going in, and we're going to see how this flows through the system and how it comes out the other side. So the first step, and this is only 17 because 8 plus 9 is, that's a cut. That's the maximum that's going to be able to flow through here. So it doesn't matter if this was 25, only 17 of it is going through, because that's the first cut. That's as much as you can get through it. So the way that we're going to figure this out is you're going to start with one pipe. It doesn't matter which one. Consider that your main flow. Everything else is going to be overflow. So if we take this path going along the top, you have to plan ahead to see how much you're going to be able to send. You can send 8 here, but you can only send 6 here, so our maximum becomes 6. Got a 9 here. That means that our maximum is going to be limited by the 6. So we can send 6, so we mark out our 8 here. We're sending 6, so our 8 is going to be reduced by 6 and made to become 2. The 2 goes up by 6 and is made to become 8, because that can be sent backwards as overflow. If we pressurize it too much, it'd come back this way and then down this way. It's not going to happen in this problem because this is a pretty simple system. So it goes up by 6. Our 6 here is going to become 0 because all 6 are going through. This increases by 6, so that becomes 9. 9 is going to decrease by 6, becomes 3. 0 increases by 6 and becomes 6. So now, at minimum, we've got 6 coming out of our T. So, but we still got more that we can send. So this 2, we want to go ahead and get rid of everything on top first. So we can send this 2 by going 2 to 5. 5 will handle 2, so 2 will make it to the middle. We can send it back up this way through this 5, and the 3 here will handle the 2 to send it to T. And basically you want to work top to bottom. So we're trying to keep everything on the top, and then we're going to move to this overflow down here. So if we send our 2, that's going to become 0. That's going to become 10. We're sending it down this pipe. So this 5 becomes 3. The 0 becomes 2. Now we've got 2 inside of B. You could send it this way, but we're trying to keep everything up just to maximize our space. So we're going to send it this way. That's going to become 3. The 0 becomes 2. That's an ugly 3. I'm going to rewrite that because I don't want to mess it up later. So now we've got 2 that we sent this way. 2 is inside of D. We're going to send that down this pipe. So our 3 becomes 1. Our 6 becomes 8. Now we've got 8 flowing out of there, which is our original 8 from over here. So now that we've got that one done, we've still got 9 that we can send, and we're going to have to find different paths to send that. So if we send 9 this way, we can send 4 more this way. Well, actually, we'll just keep it on the outside, and then we'll try and figure out a path for the last way. So if we send it down this way, then we can only send 2 here, and our 10 will handle the 2. So our limiting factor is that 2. So we'll start with that. Our 9 becomes 7. I think that was a 4, will become 6. And our 2 becomes 0. This 2 becomes 4. Because whenever this is reduced, this is increased as it goes through the pipe. Our 10 is going to become 8 because that 2 is being sent from E through the pipe. And our 0 becomes 2. So now we've got a total of 10 coming out of T, but we still got 7 more that we can send. So we want to find a path to get as much of that through as we can. We can only send it this direction because we've maximized everything from this direction. So we can only send it this way. So if we send all 7, it's going to hit this 4 and it's going to become limited. So we can only send 4 through here. We can only send 3 through here, but we still got 3 that we can send through here and 1 to go that way. So the 3 will go, the 8 will handle the 3, the 1 up here will handle the 1. So we can send 4 maximum through. And you're just going to have to make that path in your mind before you start crossing out numbers. So we know we can only send 4 here. Okay, so, oh, that doesn't become a 4, it becomes a 3 because we're sending 4. 7 becomes 3. 6 goes up by 4, becomes 10. Our 4 is reduced to 0. This becomes 4. Since we're splitting here, it'd be a good idea to keep track of what you're leaving behind. We're going to leave a 1 because we're taking this path first. So we're leaving this 1 because we know that we need to send that up here, but we don't want to lose our train right now. So we've got 1 here that we need to deal with later. Right now, we're going to send the additional 3. 1 and 3 is 4. That's what we're dealing with. The 3 becomes 0. The 0 becomes 3. Now we're sending it along this pipe. Our 8 becomes 5. And our 2 becomes 5. 2 plus 3. And now we've got a total of 13 going out. We've still got this 1 here that we can still send up this direction. And this 1 up here will handle it to send it the rest of the way. So we can mark out that 1. We're using it now. Our 3 becomes 2. Our 2 becomes 3. Now we've got 1 up here. 1 becomes 0. 8 becomes 9. Now you've got 9 and 5. And we're totally maximized. We've hit a cut here because this is 0, this is 0, this is 0. We know that nothing more can pass through there. So we're done sending anything. So we know that 9 plus 5 is 14, which is the maximum flow that you can get out of this system whenever you put in 17 or more. And that's the method.